4.1. So we're going to do 4.1, 19, 20, and 21. All right. So we want to know what happens. So what happens as we go from -4 to 4? From -4 to 4. What happened? So, did they become opposite? So we add, do we subtract, do we flip them? Right? So it's hard to tell because these are both the same. So we don't know if we rotated them. But what it looks like is it looks like x and y became negative. But we need to check that with the next one. Okay? Is that what happened? Did x and y become negative? And I see here, no. X and y did not become negative. Right? Uh-oh. Maybe I wrote this down wrong. Oh, that's not a negative. Oh. Alright, so therefore, it looks like x became negative on the first one, right? But we don't know that. So we go to the next one and we see, oh wait, the y is becoming the x and the x is becoming the y, right? This one you couldn't quite tell because they're the same number, right? But on this one you can tell they rotated, right? But then this one became the opposite. That x became the opposite. Does that make sense? And so in essence, this isn't what happened. This is what happened. Right? And then we got to double check. Is that what happened here? Yep, that's what happened here too. Okay? So that should be what happened here, and it did. Okay? So, what happens when they rotate? What do we call that? Is that reflection or is it rotation? Rotation, yeah. When these things rotate, we're going to call that rotation. But what kind of rotation? Is it 90 degrees or is it 180? Did they both become negative? No, so it's 90 degrees. But which way? Did it rotate up or down? Right? And so when we look over here, clockwise is down, right? Clockwise is down, and that's when the x becomes negative, or the new y. Okay? Is that what happened here? Right? So this is clockwise rotation. So 90 degrees clockwise. Okay? 90 degrees clockwise. Does everyone see that? Who does not see that? Because this is not an easy task. Okay? What's happening is they're rotating, so we know it's rotation. One of them becomes opposite, so we know it's 90 degrees. And then we have to think, is it going down or is it going up? And so one way you could do this is you could actually graph this and go, okay, -4 and 4, right? And then what's the next one? 4 and 4, right? So the new point, this point would be this, right? So which direction is that? Clockwise, right? And that's one way to remember it. Okay? It's just to graph it really quick. And you'll know that, oh, okay, clockwise. That's the direction it's going. Does that make sense? So a quick little graph can tell you which way it's being clockwise or counterclockwise. Counterclockwise would have went down. See what I'm saying? All right, let's do the next one. What happened between the -2's and the 2's? From what it looks like you got -x and -y, right? But again, the numbers are the same, so it's hard to tell if there's reflection plus what did I do? Did I write in the wrong number again? Right? So let's look at the next one and look, oh, it's doing the same thing. Negative x, negative y. So what is that when they both get changed? Yes. It's 180 degree rotation. And it doesn't matter which way you're going, right? Because it's 180 degrees. So, I mean, it doesn't matter if I go this way or this way, I'm still facing opposite direction. Does that make sense? Now, this could also be called a double reflection. Remember that? Because it could have reflected against the x-axis and then against the y-axis, and it would give me the same thing. Okay? Double reflection. Okay? But I think the book wants you to just think about it in one thing. And if they're asking for one translation, then it would be one transformation would be 180 degree rotation. Two transformations, it would be a double reflection. You could either go across the y and across the x, or across the x and across the y. Does that make sense? Okay? The last one. So what's happening? They're not rotating, but one of them is opposite. Right? Oh wait. No, not one of them is opposite. One's the same. One's the same. But this one, the y, is changing into a whole nother number. In fact, could I add 3 to that and get 2? And 3 plus negative 1 would be 2. Does that make sense? Would that work here? Is 3 plus 2, 5? Okay? So this is still x, but this is y plus 3. Does that work in the last one? The x's stay the same, but the 3, it's a y plus 3 again, and 3 plus 3 is 6. So what kind of transformation is that? What's it called when we're adding? Translation. Okay? Translation. And to be more specific, is it going up, down, left, or right? The y, right? So y is up or down, and we're adding 3, so that means it's going up 3. So we're going to say up 3, just to be more specific. Okay? So I want you to be very specific, especially on this state test. They might ask you, well, what is it doing? Oh, it's going up 3, or it's going to go... How would we say it goes left 2? What would left be? Negative. And to what? X or Y? X. So left 2 would be x minus 2. Up 3 would be y plus 3. Does that make sense?
How come? Like the formula, the x something's getting added to it.
So they're saying x plus a and y plus b. Well, we added something to negative 1 to get negative 1. What did we add? 0. Yeah. So in this case, a is 0. It didn't move anywhere. Does that make sense? So you do always add, just sometimes you add something that doesn't change it. Just like sometimes you'll multiply something that doesn't change it, right? If you multiply by 1, then it won't change it. Okay? Good questions. Is that good? All right, that's section 4.1.